Now, this is quite a story from NASA because for the second time in history, a man-made object has left our solar system. NASA is saying the Voyager 2 probe is now in a space between the stars after exiting the sun's protective bubble, which is called the heliosphere.
What if the edge of our solar system isn't the end, but the beginning of something entirely unknown? NASA's Voyager 2, a probe launched in 1977 and running on 1970s tech, has stumbled into a region of space so strange, so unpredictable, that it's shaking the very foundations of physics. It's not just crossing a border, it's entering a storm of cosmic mystery. Particles behaving in impossible ways. Magnetic fields that defy logic. Plasma that shouldn't even exist. This is the story of Voyager 2's discovery at the edge of our solar system, a place far more chaotic, structured, and alive than we ever imagined. Voyager 2 crosses into the unknown. For the second time in history, a man-made object has left the solar system, and this time it's rewriting everything we thought we knew. Voyager 2 has officially passed beyond the heliosphere, the sun's protective bubble, into interstellar space. That's already a massive deal. But what it found out there, that's what has stunned scientists. Launched in 1977, Voyager 2 has traveled over 12 billion miles from Earth. And just when we thought it would quietly fade into the void, it started transmitting data that made no sense. Data from a place where the rules of space seemed broken. The first surprise? The magnetic field. Instead of fading, it actually grew stronger and more organized. That's the opposite of what every model predicted. At the same time, cosmic rays surged in strange, pulsing waves, some bending around Voyager 2 as if steered by invisible forces. These weren't just fluctuations. They were consistent patterns, completely unexplained by existing theories. Even more shocking, the spacecraft's plasma instruments detected a region that didn't behave like solar wind, or like interstellar space. It was a new kind of plasma, colder and denser than expected, sitting in a strange middle zone, like a cosmic no-man's land between the sun and the galaxy. Magnetic fields gone rogue. One of the most unexpected discoveries was how magnetic fields behave at the edge of the solar system. Voyager 2's magnetometer detected something no simulation had ever predicted: a sudden, massive spike in magnetic field strength, nearly 3 times higher than what Voyager 1 saw when it crossed into interstellar space. But the strength wasn't the only twist. The direction of the magnetic field was totally different from what Voyager 1 recorded, even though the two probes exited the heliosphere relatively close to each other in cosmic terms. This raised a baffling question. Are Voyager 1 and Voyager 2 even entering the same kind of interstellar space? Some scientists initially suspected a glitch. After all, Voyager 2 is over 45 years old, powered by outdated technology and a decaying nuclear battery. But checks confirmed the instruments were working perfectly. The readings were real. This realization hit hard. It meant our models of how the sun's influence tapers off, how the heliopause behaves, might be fundamentally flawed. It's not a simple shell or barrier. It's more like a complex reactive membrane that warps and changes depending on external forces. And here's where things get even more intriguing. These anomalies might not just be random. They could suggest Voyager 2 is brushing against galactic-scale magnetic filaments, invisible threads of energy shaping the flow of plasma and particles across light years. If that's true, then the edge of our solar system isn't just weird. It's a giant magnetic frontier, possibly part of a much bigger galactic architecture. A plasma that shouldn't exist. When Voyager 2 crossed into interstellar space, scientists expected to find a slow, sparse mix of cold plasma drifting gently between the stars. Instead, the probe detected something far more unusual: a dense, cold plasma layer that behaved like nothing seen before. This plasma wasn't moving like solar wind, nor did it act like known interstellar material. It was in a strange transitional state, not solar, not galactic, but something in between. This shocked researchers, as no theory had predicted such a region. It was as if Voyager 2 had entered a buffer zone, a kind of invisible shield surrounding the solar system. Even more fascinating, radio signals sent from Voyager 2 began to bounce back with subtle distortions, phase shifts and frequency changes that pointed to structures in the plasma. These weren't just clouds of gas. They behaved like layers or folds, possibly even eddies in space, twisting and channeling signals in ways we've never seen. This isn't just weird science. It's a total redefinition of how we view interstellar space. It suggests that the transition from solar influence to galactic space isn't a clean cut. Instead, it's a dynamic boundary, shaped by magnetic fields, plasma flows, and possibly even gravity on scales we've barely begun to understand. If this buffer zone exists, it could act as a protective layer for the solar system, bending or blocking cosmic rays and high-energy particles from the galaxy. But if it shifts over time, as Voyager 2's data implies, it might also expose Earth to increased radiation during certain galactic phases. That has massive implications for our planet's history and its future. The cosmic ray puzzle. Focused from afar, cosmic rays are high-energy particles from deep space, some from distant supernovae, some from even more mysterious origins. Voyager 2 was equipped to detect them, and as it pushed beyond the heliosphere, its sensors picked up something mind-bending, an asymmetrical surge of cosmic rays. In theory, these rays should arrive from all directions, more or less equally. But Voyager 2 detected a directional bias. More particles were coming from one area of space than from any other. It was like something out there was acting as a cosmic lens, focusing rays toward the spacecraft. That's not supposed to happen. Scientists had no explanation for such focused streams. This isn't the kind of behavior you'd expect from random galactic particles drifting through space. Something was guiding them. The implications are wild. Could there be a massive magnetic structure, like a filament or bubble, channeling the rays? Or is the solar system traveling through some kind of galactic wake, like a boat leaving ripples as it moves through water? Another theory, maybe we've just discovered a region of space shaped by ancient forces. A magnetic skeleton of the galaxy formed by supernova remnants or black hole interactions. And here's the kicker. These focused rays weren't coming from the sun. Many were likely extragalactic, from outside the Milky Way. If something within our galaxy is altering the paths of rays from other galaxies, it means the space surrounding us has far more structure than we ever imagined. This directional flow of cosmic rays also raises practical concerns. If Earth periodically moves through such a stream, the increased radiation could influence everything from climate to biological evolution. It could even be tied to mass extinction events over geological timescales. The cosmic ray puzzle isn't just fascinating. It might be deeply connected to life on Earth. Plasma echoes in the hidden language of space. One of the most bizarre discoveries from Voyager 2 was the detection of plasma structures that echo like ripples bouncing off the walls of a canyon. The spacecraft began sending back data that showed delayed signals and distortions in radio waves, evidence of reflections, deflections, and something akin to acoustic resonance. Scientists initially thought it might be interference, but after ruling that out, they realized space itself might be behaving like a giant resonant chamber. Instruments recorded strange, low-frequency plasma tones, some of which, when converted to audio, could actually be heard by the human ear. These weren't random sounds. They formed standing waves, repeating patterns that suggest plasma is being contained or shaped by large-scale invisible forces. What could do that? The leading theory is that these tones are being shaped by giant magnetic or electric field structures, possibly tied to galactic currents. These structures might not only guide particles, but trap them, forming a kind of electromagnetic weather system far beyond our solar system. Even more mysterious, Voyager 2 detected sharp, localized temperature shifts, tiny pockets of hot or cold plasma, just a few kilometers across, surrounded by seemingly stable space. It's like finding a hot spring in the middle of an icy desert. Scientists now believe these may be shock fronts or boundaries within the plasma formed by energy clashes, like miniature space storms. This behavior implies that the outer solar system is far from empty or quiet. Instead, it's teeming with turbulence, boundaries, pulses, and plasma waves, a hidden language of space we're only now beginning to hear. If this area acts like a resonant chamber, it might also be a natural data storage system, where ancient solar flares, supernova echoes, and galactic energy events still bounce around, waiting to be discovered. That's not just cool, it could change how we map and measure the universe itself. An invisible architecture shaping space. One of the most paradigm-shifting ideas to emerge from Voyager 2's data is this: space at the edge of our solar system isn't random, it's structured. The spacecraft has detected what appear to be sheet-like boundaries in magnetic fields, thin, sharp edges where the orientation of the magnetic force abruptly flips. These aren't chaotic, they're clean, organized interfaces, almost like the cosmic equivalent of a tectonic fault line. What's causing this? Some believe they're the result of plasma phase changes, similar to how water turns to ice. As solar wind becomes interstellar plasma, it might undergo transitions that form these magnetic walls. Others suspect they're remnants of ancient shock waves, possibly from supernovae that exploded millions of years ago. The effect is profound. These sheets may act as natural accelerators, boosting particles to extreme speeds, much like how collider rings work here on Earth. This could explain why some cosmic rays arrive with more energy than known processes can account for. Voyager 2 also observed anisotropic turbulence, energy flowing in strips, not smoothly. This suggests that instead of dissipating evenly, energy is moving along hidden highways in space, guided by forces we can't yet detect directly. Adding to the mystery is evidence of plasma quakes, pressure waves in interstellar space that resemble seismic activity. Like earthquakes in solid rock, these waves move through the plasma medium, suggesting it's not just a cloud, but a responsive, vibrating structure. And if all that weren't enough, Voyager 2 picked up extremely low-frequency radio emissions with strange polarizations, signals that repeat and sync up with unknown external forces. They might be linked to galactic magnetic oscillations, or even to distant rotating neutron stars, whose beams are altered by the space in between. Put together, these clues paint a picture of space that is far more like an engineered system than a random vacuum. We might be seeing the galaxy's electromagnetic skeleton, a framework that guides particles, stores energy, and shapes everything from cosmic rays to plasma tone, a new kind of plasma or a new state of matter. As Voyager 2 delves deeper into uncharted territory, scientists are beginning to realize they may be witnessing the discovery of an entirely new state of matter, one that doesn't fit into any of the plasma categories we know. Inside the heliosphere, the solar wind is a familiar plasma, hot, fast, and driven by the sun. Outside in interstellar space, the plasma is cold, sparse, and neutral. But Voyager 2 is now in a region that defies both descriptions. It's denser than expected, but not hot. It's structured, but not chaotic. It behaves like a hybrid, something that doesn't obey any rules we've used before. This has sparked speculation that we're seeing a third type of plasma, or at least a unique phase transition that only happens at the very boundaries of star systems. It's a plasma that may only exist in regions where solar influence dies and galactic forces begin. And it might be stable, persistent, and far more widespread than we ever imagined. What makes this even more mysterious is how particles interact within it. Voyager 2 has recorded wave-particle interactions that don't follow conventional models. Normally, when particles interact with magnetic or electric waves, they either speed up or slow down. But these interactions seem to exchange energy without heat. That's never been seen before in space environments. This discovery hints at unknown organizing forces, maybe massive magnetic filaments or structures that channel energy with remarkable stability. These could be leftovers from ancient supernova explosions, or perhaps even shaped by dark matter, subtly influencing plasma without being visible. If this third plasma is real, it will force scientists to reclassify entire regions of the galaxy and even rethink how stars and planetary systems evolve. It could explain how some regions form planets faster, or why some star systems might be better protected from galactic radiation than others. The chemistry of the void. When we imagine the space between stars, we often think of it as empty, a dark void with nothing but scattered dust. But Voyager 2 has sent back data that turns that idea completely upside down. The interstellar medium isn't empty, it's a cosmic cauldron of complex chemistry. As it pushed beyond the heliopause, Voyager 2 detected ion species that no one expected. Highly charged oxygen ions, traces of iron and nickel nuclei. These aren't remnants from the sun. They appear to have come from distant stellar explosions, drifting through the galaxy for millions of years. This is a big deal. It means that the edges of the solar system are not just borders, but mixing zones, places where the ingredients for planets, moons, and possibly life come together. It's the galactic version of a tide pool, where material from across the cosmos swirls and interacts. Even more surprising, Voyager 2 found dust grains unlike anything seen within the heliosphere. These were smaller, more jagged, and coated with unknown materials, possibly organic films or frozen chemicals. As these particles interacted with the magnetic and plasma environment, they behaved like tiny charged bullets, occasionally triggering emissions picked up by Voyager's instruments. These observations have opened a brand new field of study, dust-plasma coupling. This was once considered a minor effect in space physics, but now it might hold the key to understanding how life-building molecules form in the galaxy. And then there are the chemical discontinuities, sharp shifts in composition, like invisible walls where one mix of elements gives way to another. These could be the result of past supernova shockwaves or even gravitational interactions with things we can't yet see. The takeaway? Space isn't just physical, it's chemical. And this chemistry could be the bridge between lifeless matter and living systems. The next time someone says space is empty, remember, Voyager 2 is flying through a cosmic recipe book, and every ingredient tells a story about where we came from and where life might be found next. Interstellar jet streams and space weather. One of the most startling things Voyager 2 has revealed is that the space outside our solar system behaves more like a weather system than a void. It's not calm, not uniform. It's filled with currents, eddies, and streams, a kind of galactic weather map unfolding in real time. Scientists are calling some of these features interstellar jet streams. Unlike solar wind, which is driven by our sun, these flows seem to be shaped by massive galactic-scale pressure gradients. They loop and swirl like Earth's jet streams, forming circular patterns of high-energy particles that wax and wane. These aren't hypothetical. Voyager 2 has detected quasi-circular particle flows, changing in direction and density over time. And they're not driven by the sun. They're likely part of a galactic current system, something that could stretch across dozens or even hundreds of light years. Even more shocking, these jet streams are layered. Some regions are thick and turbulent, while others are thin and quiet, like different weather zones in the same atmosphere. This kind of stratification has never been measured in interstellar space before. It doesn't stop there. The probe also found abrupt changes in temperature and plasma density, like space storms hitting out of nowhere. These shifts sometimes happen over just a few kilometers, suggesting the presence of shock fronts, much like cold fronts in Earth's atmosphere. And while we're used to the idea of space weather affecting satellites and astronauts, this discovery expands the concept. Interstellar space has its own weather, and we're just starting to map it. This matters because as the solar system moves through the galaxy, it may pass through different climates, some protective, others potentially dangerous. If Earth has ever moved through a more active region of interstellar space in the past, it could explain mass extinctions, climate shifts, or even evolutionary leaps. Voyager the second of may not just be showing us what's out there, it might be helping us understand what's happened to life on Earth across deep time. Space is alive, rethinking the solar system's edge. Perhaps the most profound takeaway from Voyager 2's journey is this. The edge of our solar system is not a wall, it's a living, dynamic frontier. It breathes, shifts, and pulses with activity that defies every neat diagram we've drawn in textbooks. Instead of a clean boundary between us and the galaxy, the heliopause appears to be a transformative zone. It's not just where solar wind runs out of steam, it's a place where solar and galactic forces meet, fight, and merge. A zone of alchemy where plasma changes, magnetic fields realign, and cosmic energy is reconfigured. Voyager 2 has shown that this region isn't passive, it's interactive, it evolves. It can absorb ancient shock waves from long-dead stars. It can shape the direction of cosmic rays. It might even influence the chemical building blocks of life. This boundary is not a fence, it's a membrane in a galactic ecosystem. And here's the wildest part. Voyager 2's findings suggest this membrane isn't consistent. Its shape, size, and behavior change as our solar system drifts through the galaxy. Like a boat on a river, we're moving through different currents, clouds, and structures, some protective, some hostile. This means that Earth isn't just influenced by the sun, it's potentially shaped by events and forces millions of light years away, filtered through this cosmic edge. That could explain bizarre patterns in climate history, radiation cycles, and maybe even why life on Earth evolved the way it did. What was once just the edge of the solar system is now one of the most important regions in astrophysics, a place where energy, matter, and mystery collide. And Voyager 2, running on tech older than most of us, is our humble narrator, whispering the universe's secrets back across billions of miles. If you found this journey through the edge of the solar system as awe-inspiring as we did, hit the like button, subscribe for more mind-blowing space discoveries, and drop a comment telling us what part shocked you the most. Did Voyager 2 rewrite the rules of physics, or just reveal how little we know? Thanks for watching, and until next time, stay curious.